Let's assume that you have some problem that you would like to solve with simulated annealing, and that this problem is not yet implemented in my repo. In this video I would like to give you an overview how to add your new problem to my repo, how to integrate it to it. The most important thing is the following. Check the following folder. From the root of the repo, go to source, targets. And here are already 3 already existing problems which are handled by the repo, which are already integrated to my repo. The minimal spanning tree problem, the traveling salesman problem, and the salesman angle problem. So theoretically, whenever you would like to integrate a new problem, you just have to mimic any of these and the framework will handle your problem also smoothly. Anyways, let's make a deeper view how to do it. So in lib, from the root of the repo source, lib core defines 2 interfaces, the move interface and the position interface. The move interface has a virtual function called getDelta. This means that any move class which inherits from this interface has to implement this function, and delta means, of course, how the move changes the energy level of the position. If the delta is negative, then the move can be considered as a good move. If the delta value is positive, then the move is a bad move, and most likely it will be not accepted by the simulated annealing process. There is another virtual function, size. This helps the application to track the memory layout of the program, but it's not a must to implement it, so you can leave it as it is. Let's check the other interface. The position interface is a bit larger. Any position in the repo has to be able to report an energy value, has to be able to generate a move candidate, has to be able to make a move, and has to be able to clone itself. These 4 are the must. There is a virtual function called getTypeID which will be automatically generated for you, as you will see it later. And there are also some nice to have functions, the size also for the memory layout, and plot, which is of course very nice to have, but I can, for the traveling salesman for example, it is nice to have a plot and we see how the process is solving the problem, but of course I can easily imagine problems which are not plottable because they are not a 2-dimensional problems, for example, but because they are 100-dimensional problems. So of course it's okay if this is not implemented further. In the case of your problem, then the plotting canvas will be empty, but everything else will work very, very smoothly. Let's check a concrete implementation of these interfaces. So for example, I will go to the salesman problem, include, move, salesman move is inheriting from the move interface, sorry, and it has a getDelta function implementing, just returning a delta value, and of course it has some members which is absolutely problem specific. In this case it has 2 cities which it will try to swap, and the delta value. And the position is very similar. It defines it implements the energy function, the generate move candidate function, and so on and so on, what we saw already for the interface. One more thing I would like to emphasize is a small macro magic at the end of the class. So in the position, so here is the position interface, here is the salesman position, and this has to be added to the end of the salesman position in order to make the framework realize that here is this problem, and to make the studio handle it. Basically it will register this class. This macro will register the class, and it will require, if you check what it is doing, it will make it a must for you to implement some serializing functions. So extra to the virtual functions, there are two more functions has to be implemented: the serializing function, the serializing function, and the deserializing function. Basically, a toString function and the fromString function. In case you will forget these functions, you will get a compile time error. So in total, let's count how many functions one has to implement in order to integrate a problem to the framework. These two and these four. This is total 6, and the move this one 7. So if in case you are able to implement these 7 functions, then you will have all the functionalities you already saw in this repo for your specific problem. And when this is all ready, so you are ready with the problem specific things, then just one more thing has to be adjusted. In the targets folder there is a header file called targets, and here you have to add the position header to it, and that's it. Let me add just two technical things which might be useful for you. One thing is in connection with the serializing, that serializing double values are not that trivial because of these precision problems and so on. So as you see, for the salesman problem, I'm using this rounding precision thing, and for serializing and for deserializing, I'm using also this rounding double. Basically, it just handles these precision problems. So in case it might help you also with your problem, I would like to point it out. And the other thing I would like to point out, but this is just a technical thing also, that most likely you will have to use some random values in the generate move candidate function, right? Because generate move candidate usually picks some based on some random values the move candidate. So it works so there is a class called coRandom, and you can make a coRandom object in the position class, and basically it helps you generating random values if you need. Of course, it's not a must to use it, but I recommend it to use it, so you can check how to use it. It can generate you a random number in a closed interval, or also a random double value in a closed interval. So basically that's it. To sum up, I hope you saw that the whole repository, the whole framework is very easily extendable with new problems. The main point is that you only have to make changes in the source targets folder. You have to create a new move and position. You have to implement a new move and position. The position you have to register, and at the very end you have to extend the target header. And if you are ready with all of these, you will get all the functionalities of the repository that you already saw.